Hi everybody, it's Miss Dupree. In this lesson, we're going to learn how scientists measure earthquakes. I'm sure you're familiar with the idea of an earthquake being described with a number, such as this 5.2 earthquake, or maybe there's a 3.7 earthquake. What is that number, and how do scientists decide what number an earthquake will be? Well, to begin with, scientists must measure an earthquake in order to determine how strong it was. The tool used to measure seismic waves is called a seismometer. Sometimes it's called a seismograph. Most seismometers these days are electronic, but there are still old-fashioned ones in use, and they're actually a pretty basic tool. You've got this pen with a heavy weight on it that's hanging down from a string and touching a piece of paper. And the paper is on this rolling device so that actually the paper is moving underneath the pen. So the pen doesn't move, but the paper does. So when there's no earthquake, the pen is more or less drawing a straight line. But when an earthquake happens, the paper moves back and forth with the ground movement. And this causes the line from the pen to start making back and forth lines. And the lines that a seismometer make are called a seismogram. The bigger the earthquake, the bigger the lines on the seismogram. So just by looking at a seismogram, you can get an idea of whether it was a small earthquake or a more massive one. Now, the seismometer can measure how strong an earthquake is, but it can't tell you where the earthquake happens. There's seismometers all over the place, especially in areas like Costa Rica that have a lot of earthquakes. So each seismometer is only measuring the earthquake waves at that seismometer's location, which might be like this station is closer to the earthquake. This station's further away, and so they're going to be getting different measurements. So to locate the epicenter of an earthquake, which is where it started, scientists need to take measurements from 3 different seismometers in 3 different locations. So we have a station here, we have a station up here, and we have a station here. And so the earthquake waves are going to be traveling in all directions, and they're going to be reaching each of these seismometers at a different time. And so each of these stations is going to show different measurements. The seismometers closer to the earthquake will have a stronger seismogram, and the one further away is going to have different measurements. So scientists take the measurements from 3 different seismograms, and they do some math, some different calculations, and they can work backward to figure out where the earthquake was the strongest, and that will be the epicenter. And this process is called triangulation. If you think about the fact that a triangle has 3 sides, then it makes sense that the process of triangulation requires 3 different seismometers to get enough measurements to find the epicenter. So once an earthquake has been measured, next it gets classified. Was it a mild earthquake or a strong one? How strong was it? There are 2 ways to classify earthquakes, by magnitude and by intensity. Magnitude measures the strength of the earthquake waves during the earthquake, or how much energy gets released during the earthquake. Intensity measures the amount of damage that was done by the earthquake. Obviously, a high magnitude earthquake, or one with lots of energy in the waves, will also be a high intensity earthquake, which will cause a lot of damage. But they are measuring 2 different characteristics of the earthquake: the energy of the earthquake waves and the damage that the earthquake does. So for that reason, there are 2 different scales used to classify earthquakes. And they're very similar, Both of them use numbers, and the low numbers mean a milder earthquake, and the higher numbers mean a major earthquake. The Richter scale measures the magnitude of the earthquake, and it's very mathematical because it takes an actual measurement of the earthquake's energy. It starts at 1, which is going to be a mild earthquake, probably not even felt by people on the street. And each time it moves up a number, it means that that earthquake is actually 10 times stronger. So each time you move up a level, it just got 10 times stronger. The Richter scale goes up to 10, which is a massive, incredibly strong earthquake, and there's very few earthquakes are that strong. In fact, of the top 10 recorded earthquakes in history, the strongest was a 9.5, and the 10th strongest was an 8.6. So earthquakes that are 7 or above are going to be considered pretty major earthquakes. The other scale used to measure earthquakes is called the Mercalli scale. And the Mercalli scale measures intensity, or the amount of damage caused by earthquakes. Now this one's not really mathematical. It's not taking measurements. It's using descriptions by people of what the earthquake felt like. So the Mercalli scale goes from 1 to 12. And each level has descriptions of what that earthquake is going to be like in terms of damage. So a level 2 earthquake is described as being felt by only some people, while a level 5 earthquake is going to be strong enough to wake sleeping people up, and everyone's going to feel that one. While levels 8 and 9 earthquakes are where buildings and houses start collapsing. So the Richter scale will tell you in math exactly how strong the earthquake energy was, while the Mercalli scale will use descriptions to give you an idea of how much damage the earthquake caused. And a lot of scientists use both scales together to determine how bad an earthquake was and why it caused the damage that it did. Okay, that's it for today's lesson. You should know the tool used to measure earthquakes and how it works. You should know how triangulation is used to determine the epicenter of an earthquake. You should know the difference between an earthquake's magnitude and its intensity. And you should know how the Richter scale and the Mercalli scale classify earthquakes in different ways. If you have any questions, please ask. Otherwise, you're all set. Good job, everybody. See you next time.